Alright, now that we've had pizza, I can start my little bit of presentation. So, Matt said that a few things that I was going to talk about. We added a code of conduct after a while of that, a long discussion perhaps. It's based on the Python Software Foundation's code of conduct, which is quite new. The PSF had a really short one until recently, and then they updated it, and then I took that and sort of cut it down a little bit and changed Python to MicroPython. And you can see it here, and it's not too long. But it's really just there to it says, thank you for making this a welcoming, friendly community for everyone. So that's the gist of it. Good. Now the other thing, so Bluetooth was merged very recently, which after a long, maybe probably 2 years of on and off work on that, and I think I'm really happy with how it's turned out. So there is some documentation for it and some example programs, and it will work on the ESP32 and the PyBoard in exactly the same way, and hopefully for the NRF ports and the Unix port will get support for that very soon. But I'll just show you some quick demo of it. Yep. So this is on a PyBoard D. Oh, no, that's okay. Oh no, it clearly doesn't work here. So let's see. Import. I was just debugging threading before, but this should still work. So there's a Bluetooth module and the BLE class, and just like the network module, you activate it, and so now Bluetooth is running, and we have to make, I can scan for devices, but I won't see anything because I haven't registered a callback. So let's make our callback say maybe just print out what information we get and register it. So now I've registered to receive all events at that function. It will just print it out. So the first is the event code, and then that's the payload for that event. So now if I scan again, so this will scan for 1,000 milliseconds, and we get a few events. So 16, 16, 16 are scan results, and 32 is scan end. So we can scan for a bit longer, and also increase the scanning duty cycle, so it actually listens for more of the time. And so these are all the BLE devices in range of this board that you can see. So there's quite a lot there. I'm not sure exactly what these parameters do, but yeah, you can get more and more. You can read the documentation about them. But this is just the so the first number there is the kind of address. The second number is the MAC address of the device, and then that byte array. Not sure what the false is, but the next number is the RSSI, so how far away it is. So you could filter on the RSSI to get things that are only close to you. And then the last byte array here, the big thing at the end, is the advertising payload that BLE device is spewing out. And yeah, you can decode that there's a format that it has. Basically the first number is a length, so in this one here there's 2 bytes in this packet, and that's the 2-byte packet, and then the next packet has 17 bytes, and you can write a little decoder for that. So it's pretty simple, and you can do the other thing is, so the opposite of, counterpart to scanning is advertising. So advertise with 100 millisecond duty cycle, and I can just put some numbers in there. So now this board is advertising that sequence of bytes.
Will it find itself if you do a scan?
No, because it can't listen. Unfortunately, it can't listen to itself. I don't think. But if you had another board, you could. Yeah. So yeah, I think it's. I'm pretty happy with how it works. If you look in the examples Bluetooth directory, so Jim Mosseret has done all these examples, done a lot of good work here. So the temperature sensor is a good one to start with. So it's hopefully documented and enough for you to understand. But basically it it has a demo here of setting up, creating the Bluetooth object, and then a temperature entity based on that, which will automatically advertise and have characteristics, and you can set the temperature that you want your device to see, and this loop just sets random temperature, and you can read that on a phone, so you can connect to it, and yeah, this works, and you can see exactly how it works when it registers. The key here is this register services thing, which describes the temperature environmental sensing service. So yeah, have a look at that. If you've got a PyBoard or an ESP32, it will work in exactly the same way, which is good. So I think this is a good example of an API that is exactly the same across all ports because it uses the same code.
So this is in mainline, but is it released?
It's in mainline, but it's not in a release yet,
Okay.
because the next release will be soon. Like, we just have to finish little FS, and then the next release will be out, and so this will be in mainline. Okay, so that was code content Bluetooth. There's also a few docs if you look at it. I can't really show you here, but there are some docs for that. Then the other thing that happened in the past few weeks was so the ESP32 now has a concept of boards. So there's a generic board with SPI RAM, a D2WD board, and then also a tiny Pico board. And it's easy to make your own boards now. So before, the ESP32 just had a single build, but now you can configure your build. So you can configure SDK config parameters, like default frequency and stuff, whether or not you have Bluetooth enabled, whether you don't have SPI RAM. And you can also add frozen files and other things as well. So it's fully configurable, like the STM32 port. So STM32 has a lot of boards. It's like 40 boards or something. And also the same thing was just as well recently done for the 8266. So that has just a generic and a generic 512K, but you can use that framework to define your own boards there as well. So that's all trying to become the same. So that's boards. And then sort of as part of that, there was this thing I wanted to do for a while. Instead of for frozen modules, instead of having a bunch of symlinks in a directory, to actually have a manifest of files that you want to build into your firmware. So just to show you some examples of how that works. So when you define an ESP board, for example, there's a manifest file which is describing what Python code you want to build into the binary. So it's saying that I want to put in everything that's in the modules directory, and there's some magic environment variables here to get you to the right directory. So the port dir will be the ESP8266 dir, and the MPY dir will be the root of the MicroPython repository. So you want to include everything in the modules directory. From the tools directory, I want to include these files. From this drivers DHT directory, I want to include just dht.py, and then I want to include everything in drivers one wire. So when you build the ESP8266 port with this manifest, that's the bunch of frozen files that will be included. Previous to this, you just had to create a directory and you put all your files in there and then just point the build system at that directory. But that is not as flexible as having this kind of thing. And I know this seems a little bit more complicated, but the old thing is still supported. If you want to do it, you can just do make and you do frozen. Before you had to do frozen MPY dir equals, say, my dir, but now you just do frozen manifest equals, and then in quotes freeze my dir, and then in quotes again my dir. Okay, so that's the same as the previously my dir. So this is the old way of doing things. and then this is the new way of doing exactly the same thing. So as you can see, it's just a bit of Python code that you're sort of executing there. But if you want it more sophistication, you create an actual manifest file, and it's just normal Python code, and then just add a bunch of these freeze directives. So for the ESP32, the manifest, yeah, it's a bit more complicated. It's actually pulling in stuff from the ESP8266 port. And you can also do things, so there's a release manifest, which includes the base manifest here, and then adds a bunch of stuff from the MicroPython library. And actually, I think the ESP8266 has the same thing. I added this the other day. Yeah, so here is the H66's release manifest. So it includes the base and then some drivers and UASync.io and requests and some examples and UMQTT. So hopefully these are good examples of how to use this feature, and that you can see it's much more powerful than having a bunch of symbolic links in a directory. You can also, if you have a look, the Unix manifest, you can also pass optimization options along to say how, if you want to optimize the building of that file. So yeah, there can be more features. You know, this can be much more powerful. You can write arbitrary Python. You know, if release build, and do other stuff, for example. But you know, okay. So yeah, that's that feature. So I think that's the 4 things.
Yeah,
I think that's it.
Really good. It works under Windows without some.
Yeah. Oh, you did test it?
Tried it, yeah.
Oh, great. Okay. Yeah. The whole aim of that was because before Windows 10, yeah, it didn't like symlinks, so the aim there was to get rid of symlinks. But Windows can deal with symlinks now, I think, if you.
Oh, it's
But this is good because there shouldn't be any symlinks left after this. So yeah. Anyway, check it out, and hopefully the release 1.12 will be very soon, and then everything will be available officially. So thanks for listening.